Now in this section we'll see the IP addressing used for the multicast applications. Now multicast applications uses a special address range, and that range comes under the category of D class, and the range from 224 to 239. Now we know that IP addressing is categorized into 5 classes: class A, B, C, where we use class A, B, C for the LAN and the WAN, whereas you have a class D is reserved for multicasting. Now if you want to host any multicast services or multicast server or multicast host, we need to use this class D address range, which comes under comes in the range of 224 to 239. So every multicast address is going to represent a multicast application, and it's typically referred as group address. Now INA has reserved this class D address for the multicasting. Now let's take an example. There is a server which is sending a multicast streaming for selected receivers. Now when it is sending a multicast streaming to that particular receivers, it's not going to send to the exact IP addresses. Let's say the IP address is 10.1.1.2, 10.1.1.3, 10.1.4, but instead it will be sent to the group address. Now the group address will be the multicast address, and the destination address will be something like 224.0.0.5, and this is the address which is used to identify the group, and whoever the user wants to receive the multicast traffic, they will join to this group and they get the multicast service. So the class D address is used, and when the multicast traffic is sent, the destination address will be always the multicast address. So it will not be the address of the receiver address, it will be always the multicast address range, and we call it as group address. Now according to INA, the multicast address range comes under the category of 224 to 239. Again, this address range is further classified into different categories, like we have a permanent multicast groups and source specific multicast and private multicast address range. So the first one, let's see, in the permanent multicast groups, which comes in between the range of 224.0.0.0 to 224.0.1.55. In this we have two different ranges, one for the non-routed purpose and the other one is for routed purpose. Now the basic difference between these two is, so all the addresses whichever starts with 224.0.0.x, x represents any number from 0 to 255, they are reserved for the network protocols on the same local segment. Now same local segment means these addresses will not be forwarded to the next routers, and the default TTL value will be 1, and the router do not forward these packets within this range. Like maybe you have two addresses, 224.0.0.1, which is used by the host, multicast capable host. Let's say you have some multicast capable PC in your network or a host in the LAN, and you want to check the connectivity and you want to get a reply from all the hosts who are running the multicast traffic. Probably if you ping to this, you will get a reply from those devices. So all the multicast enabled hosts listen on this 224.0.0.1, and whereas all the multicast enabled routers listen on 224.0.0.2. Now they work only just one hop away, so the routers will not forward this address range to other routers. Now similar way we have some other multicast address range like 224.0.0.5 and 6 used by the OSP of messages, 224.0.0.9 used by RIP version 2, and 224.0.0.10 used by EHRP protocol, like that. So it is reserved for some protocols which works just less than one hop, which works in the same local segment. Now these are some of the examples of those non-routed range permanent addresses. Now the next thing, there is a routed purpose range. Now this is again reserved for some kind of protocols, and those protocols that are forwarded in the entire network. Now these are just quite opposite to the non-routed address range. This works only just one hop or less than that, and the default TTL value is 1, but here it's not like that. So the routers with this particular group address, it will be forwarded to the next routers. And again, these are reserved for some protocols, like there is an address of 224.0.1.39 and 40. These are reserved for PIM RP messages. We'll talk about PIM RP rendezvous point in the next classes more in detail about that. but it's one kind of multicasting as well. Now we call those address ranges are routed purpose range. And then there is a source specific multicast. The entire address range of 232 is reserved for source specific multicast. We use this in IGMP version 3. We'll talk about IGMP and versions in the later on sessions, and we have a separate section dedicated for understanding the source specific multicast, where in case of source specific multicast you can decide if there are two servers sending a same multicast stream, you can decide from which source you want to get the multicast traffic. It's a one kind of multicast advanced implementations. We'll talk about more on this SSM features in the later on advanced topics of the multicasting. And then finally you have another range called private multicast address range, and this address is used for the range of private multicast domains used within the same organization, we can say, or on any organization who want to use this address within the global multicast application. So it's like, within your company, if you want to run any multicast application, more like a private IP address, you can use this address range. Now these are some of the addresses which are reserved for specific purposes, and that's the complete address range. As you can use any address range for hosting any multicasters, but if you're using some specific based application like SSM or for some routing protocols, we use this range, and for the private multicast addresses we use this range. But in general, we can any other addresses we can use for hosting any of the multicast traffic.